Okay, so problem number 3, I'm not going to go through each step because it's very similar to the one we just did. So I wrote down the variables here and the steps also. So use the information to calculate the initial velocity, voltage, potential difference, the final potential difference, the difference in potential difference, which is voltage, and the change in potential energy. Using those, I'm going to write these down. You might want to pause the video. Okay, you can see that it lost potential energy as it moved closer to, as the charge moved closer to the fixed charge, it lost potential energy because more of it got converted to kinetic energy. Okay, take a look at number 4 while I set it up. Okay, so on this one, the problem says the object starts, so it's initially placed at 2.4 meters and then it's allowed to move. If you notice though, they're both negative charges, so it's going to want to move away. So if the article travels 1.5 meters, it's going to get 1.5 meters farther away. So it's going to end up 3.9 meters away. And we want to know what its velocity will be. Now this is another place where I get confusing because V can stand for electric potential or velocity. In this case, it's standing for velocity. That's the unknown that we're trying to find. So initially, the object is at rest, so it's all potential energy. So what we want to do is find out what the change in potential energy is as it moves from here to here. All of the energy that is the potential energy that's lost has been converted to kinetic energy. So find your initial voltage, electrical potential. Find your final, and then use this equation to determine what the change in potential energy will be. This should be change. That should be delta V. Okay. So pause while I write it on here. So you see when you get the change in potential energy that the units cancel out and you will be left with joules. Okay, so that's the change in potential energy. It lost potential energy. So all of that potential energy that it lost got converted to kinetic energy. We know the formula for kinetic energy, same as what you've learned before, 1/2 mv squared. So that kinetic energy is going to be that value. We know mass is given to us in the problem. We can use that to solve the only unknown, which is V. So go ahead and do that. Might want to pause the video. I'm not going to work it out step by step. I'm just going to write the answer here for you. You'll remember you'll need to take the square root because this is V squared. And there is your answer. That is how fast it is traveling at that point. Okay, we are going to do 2 more problems here. You know what you're doing? You might want to go ahead and just do the problems and come back later and check to see. Or you don't even need to finish the video if you know what you're doing. I'm going to write all the variables in. This is for problem 5. This problem is really just like 4. So as I write the problem down, I'm not going to explain because it's really nothing different other than the numbers than what we just did. Oh, and I see that it's centimeters. I'm going to convert that to meters. If you get confused with electric potential and velocity both being V, you can write velocity or something to help you know the difference. So this is the steps. Okay, there you go. That's problem 5. Okay, so I'm going to go through problem 6. Now, I want to encourage you guys to, at home, go through all the practice problems. Go through all the on your own problems if you're having trouble with this concept. Look at the examples in the book. A lot of them are just variations of the same thing. Once you get comfortable using the equations, you just got to figure out, just like any physics problems, what variables they're asking you to find. Okay, so let's do number 6. I'm going to write down all the variables again here. You can do that as well, so you know what you're doing. So this one, You're wanting to know where the particle ends up before it stops. So you know if an object is moving, it's got kinetic energy and potential energy. But once it stops, that means it's not moving, so all its energy is potential energy at that point. So keep that in mind as we solve this problem. We want to know the point where the kinetic energy equals 0. That means it would be all potential at that point. Okay, so we're going to start with finding the initial kinetic energy using this equation. We know its velocity. Its initial velocity. And if you look at the charges on this, it's a negative charge being shot at a negative charge. So it's going to move towards the negative charge just initially, but it's going to start slowing down because like charges repel. But it is going to move closer before it starts turning around. That's what we're trying to find out. At what point does it get close enough that it stops moving and starts going the other direction? Okay, so find its initial kinetic energy, plugging the numbers in, mass and velocity squared, 1/2. So the initial kinetic energy is 1.4 times 10 to the 4th joules. So that means when all of this potential kinetic energy is gone, it's going to be all potential energy. So the change in potential energy is going to be that amount. We know that the change in potential energy equals Q times the change in electric potential. So we can use that. We know Q. We can use that to solve for delta V. Delta V is going to be minus 1.3 times 10 to the 6 volts, which is the same as newtons times meters per coulomb. You got to get comfortable interchanging the different units here too. So that's the change in voltage. We know the initial. We can calculate the initial because we know K, always, we know Q, and we know the initial radius. So putting those numbers in, this is R1. Oh, wait, yeah, R1. Okay, we can calculate the final. Remember, delta V equals velocity final minus velocity initial. So velocity initial plus delta V equals, I'm sorry, I'm saying this velocity, but it's not velocity, it's electric potential. So calculate delta V, which is, okay, now we can calculate R. Using everything we know, and we get for the answer 2.2 meters. That's how far it traveled. That's where it ended up. If you notice, it started at 2.3 meters. It only traveled 10 centimeters, and then it turned around. Okay, so that is most of the extra practice problems for this chapter. I am not going to go through problems 7 through 9, at least for now, or 7 through 10. The capacitor problems I think you'll find to be a lot easier, so I'm not going to go through them right now. So that's it for the first video lesson. I hope it helped you. Always send me questions, email, text, Facebook page, whatever. I'd be glad to help you out. So have a good week, and I'm sure I'll be seeing you next week.